You know the drill. You sit down in a dark room, stare at a glowing monitor, and drop a prompt into a blank text box. For years, AI operated exactly like a vending machine. You punch in your request, and the machine drops a literal, rigid response right back out, totally blind to the context of what you actually need. Ask an older model to code a network graph, and you get a chaotic mess. Without an explicit prompt for a damping coefficient, nodes bounce off the walls forever. Eventually, it burns its token budget, freezes midair, leaving a broken application. These systems lacked the situational awareness to realize humans don't want menus that never stop vibrating. Without an explicit directive on friction, the AI simply couldn't anticipate the spirit of the request. To actually get work done, artificial intelligence has to stop acting like a compliant robot following literal keystrokes and start grasping the actual goal you are trying to accomplish. Claude 5 abandons the fixed token budget completely. Instead, it relies on an intrinsic reflex called adaptive thinking, fluidly adapting its processing time to match the exact complexity of the problem in front of it. You control this through 4 distinct effort levels. You keep it on low for a quick spell check, but switch to max effort when you require serious strategic planning. Let's say you drop a request on max effort, asking the model to build a comprehensive 4-week content and promotion calendar for a YouTube channel. An older model reads that prompt and immediately prints out generic video topics and standard posting times, assuming that speed is the only metric of success. But Claude 5 hits the brakes. It maps out the steps required, realizing it lacks critical information. Rather than guessing, it turns around and interviews you, asking for your niche, subscriber count, and posting cadence. It fills in those gaps before writing. An intelligence that identifies its own blind spots and asks for directions is far more useful than one that types out a confident, inaccurate guess. This shift from guessing to reasoning scales up even further with Fable 5. This model belongs to a new tier called the Mythos class, designed for long-horizon, autonomous execution. You hand Fable 5 a project brief to build a fully functional YouTube Summarizer Chrome extension. Close your laptop at 11 p.m. and go to sleep. Deep into the night, the model starts compiling the code. 2 hours in, it hits a deprecated API endpoint and throws a fatal error. A traditional tool would crash here, but Fable 5 reads its own error logs, diagnoses the failure, and tests alternative routes. It rewrites the broken module, bypassing the dead endpoint, and compiles a working prototype by the time your alarm goes off. It stops acting like a syntax generator and starts actively managing its own failures without needing a human to reset the system. This level of durability shifts the entire value proposition. When a model navigates its own obstacles, it eliminates the hours a human would normally spend troubleshooting a stalled task. As these models begin to reason through their own logical gaps, the focus shifts away from the intricate phrasing of the prompt. You don't have to memorize specific vocabulary tricks, complex XML tags, or bizarre formatting rules to coerce the AI into generating a coherent output. Your role changes from programming a literal machine to managing a highly capable employee. You provide the context, the constraints, and the goal, and you let the model figure out the tactical steps to get there. A larger context window and faster processing times are helpful, but the actual breakthrough is having an assistant that actively participates in the problem-solving process. That blinking cursor has evolved past a simple command line interface. It is the entry point to a collaborative, reasoning workspace.